Hey guys, we're talking about matrices now. So this unit is a little short. It's pretty easy to wrap your head around, but there are some specific things that you have to be aware of. And if you need an extra hand or two, that's what these videos are for. So if you're wondering about what matrices are really for, imagine this scenario here. So you run a store, and the store sells 5 different types of products, and you keep an inventory every week. Create an inventory list that covers a 4-week period. So while you were covering your math project, most often or most likely you covered how to use Excel, use spreadsheets, use tables, and all these things. So really, let's say I have 5 different types of products. So product A, B, C, and D, and E over on the left-hand side. And then let's say I wanted to cover this over the 4-week period. So week 1, week 2, week 3, and week 4. So let's say that I had 10 of item A, 12 of item B, 13 of item C, 14 of item D, and 0 of item E in the first week, and then so on and so forth. So I'll create some numbers here, just making these up as we go, and depending on what these items are, obviously the shopkeep or yourself might have some different input here, right? So you can track these things over time. And what we'll notice about matrices is a lot of times it's really good to track things. It's really good for computer science to know where all of these numbers are. And so on and so forth. So let's just finish these up here. I'm using 13 a lot for some reason, lots of 4s, lots of 9s, and let's finish off with the 6. So this in itself is a traditional table. So week 1, week 2, week 3, week 4, and then item A, B, C, D, E, and so on. What a matrix does is it stores this information, but without these labels on the columns and without these labels on, these are columns, the labels on the rows as well. So here what we're left with is this big pile of numbers that someone may or may not want to do some math with. So imagine you're tracking your 4-week period and you want to know the price of all of these things and have a total income. So really that's why we need to translate these tables sometimes into matrices. And usually we show matrices that'll look like this, and if I were to give this a label, this could be matrix A is equal to all of these things here. So that's really what we just talked about. A matrix is a rectangular array of numbers arranged in rows and columns. And I mentioned just now computer science. A lot of times arrays is used to store many, many numbers all at the same time and do many manipulations all at once. So if you're a computer science junkie or if you're somebody that has that on your brain, this is one of the things that really helps to organize a bunch of numbers. So here, this is really just a different way to look at some things. Now, let's say that I have matrix A, and it's going to be, let's look at these numbers here. So 4, 5, 6, and 7. And we need to be able to describe things like this, right? So in order for us to talk about matrices, we need to talk about the order, right? So the order is really the number of rows, which is m, right? So m is the number of rows, and columns is n, so the number of columns. So here I have 2 rows, and remember that rows are horizontal. And if I were to remember that horizontal is a row, it's just because the H-O-R, that R sound in there reminds you that it's going to be a row. And vertical is going to be columns. So columns are running up and down. So just remember that as we go here. So this one has 2 rows running horizontal, and it has 2 columns. So the order of this matrix is going to be a 2 by 2 matrix, right? So there's 2 rows, there's 2 columns. Now if I were to have matrix B, where I had 1, 0, 3, and 4, that would just be a single row, so that would be an order of 1 by 1, 2, 3, 4 columns. So this would be a 1 by 4 matrix, right? There's more examples of this in your book, so you can identify those and begin to get used to what the order of these things all might be. Okay, so we're cruising along here, matrices. A lot of simple things happen with them, but this one can get a little bit tricky. So they have some pretty simple properties. So the first one, of course, being that equality. So if two matrices are equal to each other, each element is the same. So if I were to have a matrix, and just for simplicity, I'll draw a 2 by 2 matrix where I have values A, B, C, and D, and I'll give you a concrete example with these afterwards with real numbers. But let's say that this is X, Y, Z, and I ran out of letters, so let's call this Q. So because of the placement, now each section in one of these things is called an element. So in the top left-hand corner, this A is an element. This is the element here. We have an element here, we have an element here. All of these things are called elements of the matrix. So each individual position will be equal to the same position in the other matrix. So here in this sense, we can say that every single thing in here has an equal partner, where A is going to be equal to X, right? So A is in the same position as X. C is going to be equal to Z, and Y is going to be equal to B, so B is equal to Y, and then finally D is equal to Q, right? So this is just saying that if it's in the same spot, if it has the same element spot, then it's going to be equal to the same element in another matrix. So you might be wondering when this might apply. You'll see matrices where you might have to find out what a variable is when you actually have a number. So I'll do one of those now. So if I say that I have 8, 6, 4, and 3, and this is going to be equal to a matrix that says A, 6, 4, and 3. So looking at it here, I know that 6 is equal to 6, 3 is equal to 3, 4 is equal to 4, 8 is equal to A. So what must that A be equal to, right? So 8 is equal to A. That means that A, of course, must equal 8, right? So this is a pretty easy example. There's some more complicated ones in your textbook that requires you to think a little bit more and use some algebra, and I trust that you'll be able to find those and work through them accordingly. Okay, so we also need to talk about addition. So if matrices have the same order, they can be added. So remember that order is the m times n number. So that equals the order, where m is the horizontal rows, right? So this is in rows, and this one is in columns. I always forget that n in columns. So we're talking about the order here. So if they have the same order, they can be added. So here I'm going to draw 2 by 2s are my favorite type of matrix. You'll see those a lot this year. So 6, 8, 4, and 2, plus, let's say, another matrix here where we'll have 4, 2, 6, and 8. So that means we add the same spots. So the same element gets added. So the element in the top left-hand corner is 6. Element in the top left-hand corner of this matrix is 4. That means I can add those two. So 6 plus 4 will give me 10. 4 plus 6 will give me 10. And 8 plus 2 will give me 10. And 2 plus 8 will give me 10, right? So I picked ones that will give me all the same answers just for simplicity here, but you can actually add them. Now note that if I have a 6, 8, 4, and 2 matrix here, and I add it to a, let's say, a 3 by 2, so let's say 3 rows, so 3 rows, 4, 6, 5, and 2, 3 rows and 2 columns. So the order here is different. This is a 2 by 2 matrix. Right, so this here is 2 by 2. This one right here is 3 by 2. So there's 3 rows and 2 columns. These, because they cannot have the same order, they are going to be no solution. So you cannot add those two together. Okay. And of course, if we're going to be adding things, you would imagine that we're probably going to be able to subtract things in the same way. So if you thought that, bang on. So here we're going to have an example where I'll have my 10, 10, 10, and 10 matrix, just for simplicity, so that way we can work with that. And this looks a little funky here, let's fix it. And so we can subtract the same style, right? So again, it has to be the same order. So in order for me to do that, I'm going to show you a 2 by 2 matrix. And so from here, I'm going to say 10 minus 8 is equal to -2 in my top left-hand corner. Oh, sorry, 10 minus 8 is just equal to 2. I had negatives on the brain because I needed to tell you something about that. 10 minus 2 is going to give me 8. 10 minus 4 gives me 6. And 10 minus 6 gives me 4. So inside of these, you can also have negative numbers. So you can have negative numbers negatives in matrices, in a matrix. So don't just think that these are positive values only just because the way that we've been doing them has been positive values only, but ultimately you can have negative values as well. You can have variables, you can have fractions, you can have any type of real numbers that you might see in any other math class in the run of a day. All right, so last but not least, we have to talk about multiples of matrices, and again, this is a pretty simple and straightforward concept, but we still have to cover. So here, if a matrix has an order of m times n, and k is a scalar. So we talked about scalars kind of briefly before, where we multiply them in our vectors unit, right? So k is just multiplying every single component or every element inside of a matrix by that number. So instead of looking at all this stuff up here, really we can do an example. So let's say that I have a matrix that's, let's go a different one we haven't seen before, 1, 3, and 6. So this is a 1 column, so that's it, or sorry, 3 rows, 3 rows by 1, so that's our order. It's a 3 by 1 matrix. Now let's say, excuse me, let's say that we want to multiply this whole matrix by 3. So what we can do is we can just put a 3 in front of that matrix. Now if this were to be denoted as matrix A, we can express this as saying 3A is equal to 3 times that 1, 3, 6 matrix. And if we wanted to get the answers, it's just 3 times every single thing inside here, and we're going to have the same resulting order. So we're still going to have a 3 by 1 order at the end of it. 3 times 1 is 3, 3 times 3 is 9, and 3 times 6 is going to give me 18, right? So I will go through one more example here down at the bottom with fractions, so that way you can see that this kind of works the same way, and you'll see some different variations here. So let us do -1/2 of b. So a lot of times the question will denote what the matrix is going to be to look at. So here I'm going to say that this is -1/2 of my original 2 by 2 matrix, which is 6, 12, 24, and 6. So in each thing, we're really multiplying the 6 by a -1/2, right? So that's going to be -6/2. And I'll do these all in fraction form and then simplify just to show you guys the process here. So 12 times -1/2, so that's going to be a -12/2. This one here is going to be a -24/2. And then we're going to have -6/2 as well. So if you want to, you can always simplify down to the simplest terms, and this one here will work out definitely nicely. So 6 divided by 2 is going to give me a -3. -12 divided by 2 gives me -6. 24 by 2 is going to be -12. And finally, I'm going to get another -3 down here. So that's my resulting matrix after I multiplied matrix B by -1/2. So there's all the simple things and the introductory things that we can do with matrices. Next up in your checkpoints and on your videos, we're going to talk about how to multiply matrices, so that way we can get into things talking about money and the original example that I showed you, where if you have inventory and you know the price lists, we can multiply them together to get a total price for your operation for the week.